Oh, hey, here's a quick review on trig substitution. For the test, I decided to put a problem on there where it tells you to do the trig substitution but not to finish the integration to save you some time. So let me show you what that's like. Here's a few problems from the review. So you may have already tried them, but let me show you how to start them just to the point where you've done the substitution and everything's in terms of theta. And that's where I'll stop. So the first one is number 17 from the review. Square root of 16 minus x squared. So that means the triangle looks like this. It's got 4 because that's the square root of 16, and an x on the opposite side from theta, 4 on the hypotenuse. And that's so that I can finish the triangle with the square root of 16 minus x squared, which, if I check it, obeys the Pythagorean theorem. Squaring that gets rid of the square root, add on the x squared, and that's the same as 4 squared, 16. All right, now, this is the one where then I look at the sine of the angle, and it's x divided by 4. So I can write that as x equals 4 sine theta. And I have a dx equals 4 cosine theta d theta. And I also have that the cosine of that theta is equal to the adjacent divided by the hypotenuse. So I can write that the adjacent there, square root of 16 minus x squared, is going to be equal to, well, let's see, say it again. Cosine is equal to the adjacent over the hypotenuse. So this is exactly equal to 4 cosine theta. Right? Which you can also get by plugging in 4 sine theta for x in this. Do it the algebraic way if you like. So that means I can rewrite my original pretty quickly. The square root of 16 minus x squared turns into 4 cosine theta. And the dx turns into 4 cosine theta. So d theta. So I get 16 cosine squared theta. So the rewrite of this would be the answer if I stop here as 16 cosine squared theta d theta. Make sure that you can see that. Back up. That's the final answer on that one. If I say stop there, once it's rewritten in terms of all thetas, you can stop. And then if you want to finish it out, you can do that and check your answer. But that's all I'm going to ask for. So for this one, I have a square root of x squared minus 16. For comparison, the square root has just the other order underneath it. Now when I have that means that I switch everything around. I put x on the hypotenuse instead of the 4, which kind of has that same place. And then, however, I'll put 4 down on the adjacent, and the square root will go over here. Square root of x squared minus 16. And now the substitution that works the best is actually secant. It looks almost like cosine because cosine would be 4 over x. But I don't want x in the denominator, I want it on top. So I use secant. Secant is equal to x over 4. So I use, squiggle here, x is equal to 4 secant theta. And then dx is equal to 4 secant theta tangent theta d theta. And I have that square root of x squared minus 16 divided by 4 is equal to the tangent theta. So I can write square root x squared minus 16 equals 4 times tangent theta. Check that that works. Just divide through both sides by 4 and then look back at the triangle for opposite over adjacent. And that gives me enough to substitute. I can substitute 4 secant theta in for the x. I can substitute, I forgot my dx on here. I can substitute in the 4 secant theta tangent theta d theta for the dx, and I can substitute in the 4 tangent theta for the x squared minus 16. Remember that this also would be something you could find by putting in 4 secant theta for x, if then you use trig identity, but you can also use the triangle. All right, so the final answer for that one, let's see. I get 4 secant squared, or 16 secant squared for the x squared, and on top I have 4 secant theta tangent theta d theta. So let's see, I might have to erase this for the last one, but that'll be okay. So the answer for this one would be the integral, all of the dx on top turned into 4 secant theta tangent theta d theta. And on the bottom is that x squared, so 16 secant squared theta. And the square root of x squared minus 16, which is 4 tangent theta. And then you can substitute, or you can cancel some things. Tangent on 4 tangent theta on top and bottom both cancel, and the secant theta on top cancels with one of the secant thetas underneath. So it cancels out a lot. So we could do that, cancel, and have just 1 on top, and left with a 16 secant theta on that bottom. So that'll work. Hey. All right. So for the last one, this is actually not on the review page, but it was one of the ones we did in notes, so I thought I'd put one in here for comparison as well. It has square root of x squared plus 4. So when they're added together, that's when you use the tangent, because you can put x on the opposite, 2 on the adjacent, and then the hypotenuse is the square root of x squared plus 4. So for this one, I'll use x is equal to, so look back at it again, tangent of the theta is x over 2. So x is equal to 2 tangent theta. Let's see, dx is equal to 2 secant squared theta. So there's those 2 parts of it. And the square root of x squared plus 4, that is the hypotenuse, and in terms of the triangle, that's going to be useful to think of that as being using the secant, because the secant of theta is the square root of x squared plus 4 divided by 2. So I think I can go and erase the previous answer from here. And to finish finish this one now, I want the, the third part of the substitution is that square root of x squared plus 4 is going to be equal to 2 times the secant theta. And that's from the triangle, or by filling in 2 tangent theta for x and doing the algebra. All right, now we can, forgot the dx on here again. I won't forget that on the test. Now we can go ahead and plug in the 2 secant theta and the dx. So the final answer would be the integral of 2 secant theta. That's the square root of x squared plus 4, and dx becomes 2 secant squared theta d theta. Forgot writing d theta down here too. And we could simplify that a little bit to make it 4 secant cubed. D theta. All right, so there's the substituted version of that one. And these can be kind of difficult even from there to finish integrating. And that's why I decided to put one on the test where all you have to do is the substitutions. So you have to draw the triangle. It'll be one of these 3, and then do the correct substitutions into the original integral. And as soon as it's all in terms of theta, you can simplify it a little bit, maybe, and you'll be finished at that point.